Remember Marvel's Helicarrier? Yeah, that flying battleship that looked like a bad Photoshop. Now imagine the Pentagon watching that movie and going, wait, what if we actually did that? Then came Space Force. Half the planet laughed, the other half opened CAD software. Suddenly, Make the Galaxy Great Again wasn't a meme. It was a budget request. Now, engineers are actually turning those memes into machines. DARPA's orbital platforms, China's Jiu Tian swarm-mothership, private Gravitics carriers hanging in near space like Death Stars with corporate logos. So buckle up, because the sky is about to get crowded. And this time, the flying carriers are real, loud, and huge. How sci-fi flying carriers became classified. The idea of a flying aircraft carrier sounds like something straight out of Marvel. But decades before Tony Stark, the US Navy was already trying to build one. In the early 1930s, the Navy launched two massive airships, the USS Akron and USS Macon. Each stretched more than 240 meters in length and carried 4 Sparrowhawk biplanes stored inside a hangar bay. The planes were lowered through a trapeze system and released in mid-air, then caught again with a skyhook. It worked until physics intervened. The Akron was lost in a 1933 storm off the New Jersey coast. The Macon followed 2 years later. 73 men died, and the Navy quietly abandoned the concept. The first lesson was clear. The sky can lift your dreams and drop them just as fast. 3 decades later, the idea resurfaced in the Cold War. Nuclear engines, jet propulsion, and radar made engineers believe the impossible was suddenly negotiable. Lockheed's CL-1201 proposal imagined a 1,120-foot span nuclear-powered flying base that could remain airborne for over 40 days. It would host 22 fighter jets, a crew of 800, and weigh more than 5,000 tons, effectively an airfield with wings. The design never left the paper phase, but it showed how far Cold War logic could stretch when budgets were limitless. Boeing followed with the airborne aircraft carrier 747 concept in 1973. The plan modified a commercial 747-200 airframe to carry 10 microfighters called Model 985-121, each less than 8 meters long, and launched through the cargo bay. Recovery used a retractable arm and docking cradle. Simulations suggested it could work, but the cost was prohibitive, and the microfighters had nowhere near the endurance of full-size jets. The project died quietly, but its blueprints would resurface decades later in DARPA archives. By 2014, the dream was back, this time driven by unmanned technology. DARPA announced Project Gremlins, an attempt to transform existing aircraft into reusable drone carriers. The goal? Deploy small autonomous vehicles from a C-130 Hercules, have them complete reconnaissance or strike missions, and recover them mid-air. Each drone, designated X-61A, measured 4 meters long, with a wingspan of 5.5 meters, and cost roughly $700,000 to produce. It could carry a 27-kilogram payload, fly over 400 kilometers, and operate for several hours. Flight tests began in 2019. The first 3 attempts came within centimeters of a successful retrieval, before turbulence disrupted the capture. In 2021, DARPA achieved the first full mid-air recovery in history. A modified docking arm extended from the cargo bay, locked onto the drone, and pulled it aboard at 225 kilometers per hour. The mission validated what engineers had chased since the Akron, a reusable airborne platform that never needs to land. The Air Force immediately saw potential. A single C-130 could launch and recover 4 Gremlins within 30 minutes, each equipped for surveillance or electronic warfare. The drones were cheaper than cruise missiles, yet reusable, offering persistence without risking pilots. DARPA concluded the system could reduce operational cost per sortie by 40% compared to conventional UAVs. Next came the Loyal Wingman initiative. Instead of recovering drones inside a mothership, the Air Force began pairing them with frontline fighters. Boeing's MQ-28 Ghostbat, developed in partnership with Australia, and Kratos' XQ-58 Valkyrie became the leading prototypes. The Valkyrie costs around $3 million per unit, flies at Mach 0.85, and has a range of 2,200 kilometers. Controlled by secure data link, it can scout ahead of manned jets, jam radars, or carry precision bombs. In trials, F-35 pilots commanded multiple Valkyries simultaneously. effectively acting as flight leaders for robotic squadrons. Complementing that is Skyborg, an AI system designed to manage these drones in real time. Skyborg processes sensor feeds, navigation data, and threat recognition faster than any human. It's not a pilot replacement, it's an extension. The digital brain that coordinates formations, prioritizes targets, and keeps unmanned aircraft aligned with mission goals. Then came Longshot, announced by DARPA in 2021 and awarded $94 million in Phase 3 contracts to General Atomics. The design is a slender unmanned aircraft about the size of a cruise missile, but capable of carrying two AIM-120 AMRAAM or AIM-9X air-to-air missiles. Longshot is launched from a bomber or fighter, cruises toward the enemy formation, and fires before the host plane ever enters threat range. It effectively doubles engagement distance for manned jets while keeping pilots safe. Test flights began at the end of 2023, marking the first step toward autonomous air combat launched from another aircraft. Parallel to that, the Air Force revived the Arsenal plane idea, turning bombers into airborne magazines. A B-52 Stratofortress, capable of carrying 31,500 kilograms of ordnance, can serve as the heavy arm of a networked strike group. Stealth fighters identify and track targets. The bomber releases long-range missiles from hundreds of kilometers away. This model allows older aircraft to stay relevant while avoiding the need for new multi-billion-dollar airframes. Individually, these projects seem separate, but together they form a clear pattern. The United States is assembling the architecture for a true airborne carrier group. Gremlins provide recoverable, reusable reconnaissance swarms. Loyal Wingman and Skyborg link manned and unmanned fighters into one cooperative network. Longshot extends their reach deep into hostile airspace. Arsenal planes deliver massed firepower from safety. Each piece feeds the same vision: a flexible, layered system where every aircraft can launch, control, or resupply smaller ones. It's the naval carrier principle translated into air power: range, endurance, and strike density without relying on runways or fleets at sea. And while it all sounds futuristic, most of it already exists in flight test data and budget sheets. DARPA's 2021 report listed over 270 successful Gremlin flight hours. The Air Force logged dozens of Valkyrie sorties, and funding for manned-unmanned teaming exceeded $1.2 billion USD across programs by 2025. But while Washington refined the technology, Beijing saw the opportunity and decided to build the sky in bulk. China's gamble and the physics that bite back. If the first wave of flying carrier experiments was American, the next surge is clearly Chinese. Methodical, large-scale, and doctrine-driven. At Zhuhai in 2024, China unveiled Jiu Tian, a blended-wing unmanned mothership reported at roughly 17 tons takeoff weight, a wingspan near 20 to 25 meters, endurance around 12 hours, and a claimed range approaching 7,000 kilometers. It can carry scores of loitering munitions and operates near 15 kilometers altitude. The concept is straightforward: launch many small attack or ISR vehicles, overwhelm defenses, and accept attrition as part of the cost model. China is also pursuing hypersonic carrier concepts. Some leaked designs revive oblique sweep or variable geometry wings and target speeds in the Mach 5 to 6 range with stratospheric flight profiles. Hypersonic launch compresses warning windows and shortens time on target, but it requires exotic materials, thermal protection, and propulsion systems. Scramjets are staged rockets that remain expensive and brittle. That brings us to the hard limits. Air launch does save fuel. Releasing a vehicle from 15 to 20 kilometers cuts delta V and propellant needs by about 25 to 35% compared with ground launch. But lifting mass to those altitudes is costly. Each extra ton of payload demands larger wing area and stronger structure, which increases weight and radar cross-section. Detection risk grows non-linearly with size. Doubling wingspan often more than doubles the signature problem. Recovery and handling add another layer of difficulty. Docking a drone in turbulence at hundreds of kilometers per hour requires centimeter-level guidance and control in 3 axes, while compensating for unpredictable wakes and gusts. Those fluid dynamic problems explain why many programs prefer expendable loitering munitions or one-way systems instead of complex recoverables. Cheaper hardware, simpler logistics, faster tempo. Payload trade-offs are decisive. A practical strike drone for these missions carries tens of kilograms of warhead or sensors, not heavy air-to-ground ordnance. That pushes doctrine towards saturation, distributed jamming, and sensor denial rather than single heavy precision strikes. Conversely, mounting heavier missiles on a mothership forces dramatic increases in airframe size and cost, often producing diminishing operational returns. Survivability is a ledger you cannot fudge. Large, slow carriers are visible to modern AESA radars, space optical sensors, and integrated ISR networks. High altitude grants range but not invisibility. Countermeasures such as long-range interceptors, directed energy, and coordinated EW can blunt swarms, particularly when defenders combine layered SAM networks, ship-based Aegis capabilities, and airborne interceptors. That forces attackers to accept standoff operations, heavier escorts, or stealth investments. So why press on? Because the strategic payoffs are real when the pieces fit. Airborne or near-space carriers buy rapid reach, assets that can reposition across theaters in hours, bypass basing politics, and launch swarms on demand. They create a cost asymmetry. Cheap, expendable drones force defenders to expend far more expensive interceptors or motors. They enable launch on demand to near space, saving propellant and shrinking deployment timelines. And they shift risk away from pilots and capital platforms onto unmanned systems. The result is an operational posture that values tempo, redundancy, and mass. For states that cannot match blue water carrier fleets or overseas basing networks, airborne and stratospheric carriers offer an alternative. Project power through numbers, rapid launch, and distributed assets rather than singular platform dominance. The sky isn't just blue anymore, it's a launch pad. Every nation's racing to build flying carriers, drone hives, and maybe a Space Force 2.0 with better Wi-Fi. Billions are flying faster than the prototypes. One wrong line of code and someone's weather balloon might start World War III. The future of air power is here. Loud, fast, and slightly insane. Hit subscribe, drop a like, and keep your seatbelt fastened. Because the next arms race is taking off above the clouds.